Okay, so this is our final radicals video. After this, we're going to be moving on. So the last thing that we want to talk about when talking about radicals is solving equations. Okay, so equations with radicals. So this is nothing new to us because we've done equations with absolute value. We've done all different kinds of equations. So a lot of this is going to be repeat, and it's just dealing with how do we get rid of a radical, just like how do we get rid of an absolute value. So we're going to start off really simple, and then we're just going to slowly add on to it like we've been doing in the past. Okay, so let's take a simple equation like square root of x minus 3 is equal to 4. And the idea here is we want to solve for x. And that's true for any equation with a radical. Our goal, it's really true for any equation, right? That our goal is always to solve for our variable. And in this case, it's x. It doesn't have to be x, right? If we used a, then we would be solving for a. If we used m, we would be solving for m. So none of this really changes if the variable, if we just call it something different. So just like before, our first step is just isolate our radical. So our radical is already isolated here, so we don't have to worry about that in this particular problem. The second step is going to be to square both sides because we want to get rid of the radical. This is our step 1. This is our step 2. So let's do that. Let's square both sides. Okay, and we know before that something like the square root of 5 times the square root of 5, or the square root of 5 squared, is 5. Same thing is true here. When you take the square root of x minus 3 and you square it, the square and the square root cancel each other out. Remember, square root of x minus 3 is really x minus 3 to the 1/2. So if we have x minus 3 to the 1/2 and we square it, well, we multiply our exponents. So I'll put this down here just in a different color just so that you can sort of see what's going on here. Okay, I'm going to put it under step 2. That the square root of x minus 3 squared, so I'm using this as an example, is really x minus 3 to the 1/2 squared, right? We can rewrite a square root as an exponent, so we just make it to the 1/2, which means this is x minus 3 to the 2/2. We're multiplying our exponents, and x minus 3 to the 2/2, well, 2/2 is 1, so that's what's happening here. A square root and a square are inverse operations. They cancel each other out. They undo each other. So we wind up with x minus 3 is equal to 16. And then we want to add 3 to both sides. That gives us our x equals 19. Okay, now before we say that's an answer, we don't want to just say it's an answer. What we want to do is we want to check. We want to check to make sure our solution is not extraneous. Talks about extraneous solutions. I'm sorry, I can't remember, so I'm just going to go through and explain it one more time. So an extraneous solution is a solution to the equation, to our new equation, but it's not necessarily a solution to the original equation. So when we square both sides, we get this new equation, x minus 3 equals 16. So x equals 19 is a solution to this equation, but it may not be a solution to this one. Okay, so that's what an extraneous solution is. So a solution to the final equation, but not the original. And to check for this, we just plug back in. Plugging it back in to make sure it works. We're saying that the equation is true, the equality holds. Now, we only have one solution here, so in most cases, this is going to hold, okay? So let's just double check. We have the square root of 19 minus 3 is equal to 4. The square root of 19 minus 3 is the square root of 16. And the square root of 16 is 4, and 4 is equal to 4. So this is a solution. It's not extraneous. Okay, so every time that we have an equation with a radical, we have to check for this. Okay, let's take another example. I'll label this number 1. Again, just so that if you're looking at the board notes, you don't get confused. So now we're going to add in a little piece that requires you to isolate the radical. So let's take the square root of x minus 4 plus 8 is equal to 3. I want you to notice something just about the radical sign. If you notice I put a little tail on here, that's just to make it very clear that the plus 8 is not inside the radical. So you want to make sure that when you write a radical and you have something after it, that you put a little tail so that it's very clear what's under the radical and what isn't. So the x minus 4 is the radicand and the plus 8 is outside. Okay, so our first step is going to be to isolate. Let's put this in green, just so that, again, you see it's a different problem. So we're going to subtract 8 from both sides. We're isolating the radical first. Okay, that's always our first step. So this gives us square root of x minus 4 is equal to negative 5. And that's fine. Okay, you can have a negative number. Now we're going to go through and we're going to square both sides. Okay, that gets rid of the radical. The whole negative 5 gets squared. So the point of doing that is to get rid of our square root sign. Okay. And that is going to leave us with just x minus 4. And x minus 4 is equal to 25. Square root of negative 5 squared is just 25. Okay, and now we add 4 to both sides because we're solving for x. So that's kind of the unspoken thing, that we square both sides and then we solve for x. And let's just put that in here. Square both sides to get rid of the radical and solve for x. Seems kind of intuitive that you would solve for x before checking for an extraneous solution, but I just want to be really clear here. So we get that x is equal to 29. And then we're going to go through and we're going to plug this in. We want to make sure that the square root of 29 minus 4 plus 8 is equal to 3. This is a great example of an extraneous solution, because what we get here, and I'm just going to put an arrow because we're running out of space and I don't want to put it on a new page. I think it's better to put it here. So we have the square root of 25 plus 8 is equal to 3, which gives us that 5 plus 8 is equal to 3. And you probably don't even need this step, but 13 is not equal to 3. So x equals 29 is extraneous. It's not a solution. Okay. And the reason that this is happening is that we're squaring a negative. Okay, so when we square a negative, whether it's positive or negative, we get a positive number here. So the fact that we're squaring a negative changes everything, because this was originally a negative number and now we turned it into a positive number by squaring it. So that's why we're getting the extraneous solution, and you'll see this in a few different places. So this is why we got extraneous here, but not over here, because here we just squared a positive number and it remained positive. But by squaring the negative 5, we changed the sign of the number. Okay, we're going to keep doing, and we're going to keep going. We're just going to do a bunch of examples. So this is our third one. So let's take square root of 3x plus 5 minus 2, and we're going to put the little tail on the radical just to make sure it's very clear that that is not part of the square root, that that's the end of it, and minus 2 is not under it. Okay, so now we're going to do the same thing. We're going to isolate the radical first, so we'll add 2 to both sides. And that's going to give us the square root of 3x plus 5 is equal to 1. And notice we get that the square root of 3x plus 5 is equal to a positive number. So we've isolated the radical, but in addition, what we have here is that when we square it, we're squaring a positive number. So we're not actually changing the sign of our number when we square it. So by doing that, it's unlikely that we're going to get an extraneous solution, but you always need to check, okay? Don't feel that just because you don't think that you'll get something extraneous, you no longer have to check, because sometimes things can go awry and you kind of find out that you do have to. So we're going to square both sides. And when we square both sides, 1 squared is 1. And the square root over here disappears. So we get that 3x plus 5 is equal to 1. So now we solve this like a linear equation. We subtract 5 from both sides. Okay, that's going to give us 3x is equal to negative 4. That's fine. Our axis can be negative. There's nothing wrong with that. And then we divide both sides by 3. So our final answer is x equals negative 4/3. So I'm going to move this up here just so that we're using all of our space. But we want to check to see if it's extraneous, so we want to plug back in. Okay, so here we isolate the radical. Here we square both sides. Here we solved for x. So notice we're following the same procedure each time. And here, we're going to check to see if it's extraneous. So we plug it back in. We have the square root of 3 times negative 4/3 plus 5 minus 2 is equal to negative 1. So notice we plug in the negative 4/3 and we put a little tail on our square root. Again, just to be clear that this minus 2 is not part of the radicand. Okay? And this 3 cancels. Okay, this is like 3 over 1 times negative 4 over 3. So what we wind up with is the square root of negative 4 plus 5 minus 2 is equal to negative 1. This is the square root of 1 minus 2 is equal to negative 1. Or 1 minus 2 is equal to negative 1. And I'm going to put a check mark here. We don't have to go all the way down to the bottom in this case. You can stop here. Sometimes you can skip a couple of steps in here. That's kind of up to you. But you do have to show that you plugged it in. You have to show that this is that you're checking to make sure it's extraneous. Okay, so if you're doing a test, even though it's not extraneous, if you just put a check mark here, that's not enough to tell me that you checked. So you need to do something. So you need to do at least one of these steps to show that you plugged it in and you did actually check for whether or not it's extraneous. Okay, so that's about communication. Okay, let's take another one. Why don't you try, at this point, I would recommend that this is where you might start considering stopping the video, pausing it, try it on your own. We're going to do a couple of these now that are going to look a little bit different, but the idea is the same, okay? So the next one is very similar to this one, but then after that, we're going to start working with cases where you might have x's, more than one x, or you might have more than one radical. So we're going to start changing things around a little bit. But again, after each one, or before each one, when I write down the problem, try pausing the video and see if you can do it yourself. The idea is the same, okay? You're isolating your radicals as much as possible, and you want to get rid of them. So you want to square both sides. At some point or another, there's going to be a squaring, okay? So let's take one more that's similar to this. So we have square root of x minus 2 plus 3, the plus 3 is outside, it's not part of the radicand, is equal to 5. And let's change our color just so that you can see these are different problems. We're going to isolate the radical first, subtract 3 from both sides. That leaves us with square root of x minus 2 on this side by itself. Okay, these 3's are canceling, that's the whole point. And this is equal to 2. And now, we're going to square both sides. So if we needed to guess, we would say, hey, this solution is not going to be extraneous. But don't always jump to conclusions. You should always double check, okay? So we're going to square both sides. The square root disappears because of this, which leaves us with x minus 2 equals 4. Then we can add 2 to both sides. We're left with x equals 6. And again, I'm going to take this. We'll write x equals 6, but then we'll take this over here just to make sure it's not extraneous. We should always be checking for extraneous, even though we suspect it's not going to be, because we didn't change any signs here. And as soon as we don't change signs when we square, it's unlikely that it's going to be extraneous. But we always want to check. So the square root of 6 minus 2 plus 3 is equal to 5. Square root of 6 minus 2 is square root of 4 plus 3 is equal to 5. 2 plus 3 equals 5. And here, you can just put a check mark. You don't have to go all the way down to the bottom. I think you can assume that most people are going to know that 2 plus 3 equals 5. That's okay. There are going to be some cases later on in the semester where you will have to go down to that very last row, but you don't have to do that here. Okay, so at this point you should be pretty comfortable with this, where the only thing that you have to do is isolate the radical, square both sides, and then solve for x. And these are cases where there's only one x and only one radical. Let's take a case where there are 2 x's and 2 radicals. And don't worry, it doesn't really get more complicated. Sometimes it's less steps. It doesn't really change your process that much. So let's say that we have 4x minus 7 is equal to 3x plus 9. And this is an example where you want to make sure it's clear that the minus 7 and that the plus 9 are under the radical sign. So I think it's pretty clear. You can just extend your radical, or you can put a tail that comes after the 7 and after the 9. That's up to you, but you want to make sure that it's really clear. Okay. And this is an example where you're just going to square both sides. The radicals are isolated, so when you square both sides, nothing is going to happen. You can do this. It's not going to cause any problems. Okay? And what this does is it gets rid of the radicals on both sides. So now we have 4x minus 7 is equal to 3x plus 9. This is a linear equation, okay? Just like these were linear equations. 3x plus 5 equals 1. X minus 2 equals 4. These are linear equations. The difference is that we have an x on both sides and we have a number on both sides. So we've done this a lot. I'm not going to go through it and explain everything that I'm doing here, but I will say that I know some of you have done this differently than I'm about to do it, and that's fine as long as you get the same answer. I don't care how you do it. Okay, so here we're going to move the axis over to the left and we're going to move the numbers over to the right. So I'm doing this in one step. You can do it in 2 steps. You can do it a little bit differently. So that means that we're going to subtract 3x from both sides, and it's going to cancel on this side, and we're going to add 7 to both sides, and the 7s are going to cancel on that side. So 4x minus 3x is just x, and 9 plus 7 is 16. Okay. And it's really important that we check for whether or not we're going to have an extraneous solution here. Here it can be a little bit harder to tell because we have the square roots on both sides, so we really have to check for the extraneous solutions. So we're going to move this up here because they think that we can fit one more problem on this page. And let's do this in our pink color. So square root of 4 times 16 minus 7 is equal to square root of 3 times 16 plus 9. And we just want to make sure that we get the same thing. So 4 times 16 is 64 minus 7, and 3 times 16 is 48 plus 9. And here 64 minus 7 is 57, and 48 plus 9 is 57. So the square root of 57 is equal to the square root of 67, which means 16 is a valid solution. Okay? Okay, let's try another one. So these guys, it gets fun because we're trying to figure out how to solve these when everything looks just a little bit different. Okay? I'm actually going to go to the next page because I think that the next problem is going to be a little bit longer and I want you to see the whole thing together. So let's take 3 times the square root of x plus 2. When I say a little bit longer, I don't mean harder, I mean just longer, an extra step or 2. And this is square root of x minus 4 is equal to 0. Okay. So this is a case where you want to get one square root on the one side and the other square root on the other side. You could square both sides at this point. The problem is that when you square both sides, remember you cannot distribute a square when there's a plus sign. So what that's going to do is it's just going to create more radicals, and it's just going to get very confusing where you have a lot of extra work to do instead of just a little bit of extra work because you have both square roots on one side. So ideally, you really want to make sure that you don't have more than one square root, because if you did, it just makes the whole problem longer. Okay? It's not that it's so much harder. It's not. It's just that you're making it longer because now you have if you're squaring it here, then remember that's 3 root x plus 2 plus root x minus 4, and then you have to multiply that by 3 root x plus 2 plus root x minus 4. You cannot distribute a square, okay? So you want to make it so you have one square root on each side. It's just going to make your life easier. So that means let's subtract the square root of x minus 4 from both sides. So now we have 3 times the square root of x plus 2 is equal to negative the square root of x minus 4. And the 3 we can't do anything about, right? If we try and divide both sides by 3, then we're going to wind up with the denominator, and who wants that? So we're just going to leave it and we're going to square both sides here. And it's okay, because we can distribute the square. We can distribute it to the 3, and then we distribute it to the square root. Okay, so here we can distribute the square because between the 3 and the radical, there is no plus sign, it's multiplication. We can distribute a square when it's multiplication. So what we wind up with here is a 9 times an x plus 2. You need parentheses because the whole x plus 2 is being squared, and that whole thing is being multiplied by 3 squared. Okay, so the 9 came from 3 squared. And then here, a negative squared becomes a positive, so this is just x minus 4. Okay, so the 9 came from 3 squared. The square root of x plus 2 squared is just x plus 2. That needs to go in the parentheses. Here, a negative squared becomes a positive, and the square root of x minus 4 is just x minus 4. Okay. Now this is a linear equation, so the next thing that you would want to do is distribute your 9. And we get 9x. Oops, sorry about that. We get 9x plus 18 is equal to x minus 4. This is so that we get that linear equation written in a way that we can easily solve it. Okay. And now again, it's linear. We move our x's to one side and our numbers to the other. So we can subtract x from both sides. And we could subtract 18 from both sides. Again, if you do this a little bit differently, that's okay. Our 18 cancels and our x's cancel. And now what we have here is 8x is equal to negative 22. Okay, negative 4 plus negative 18 is negative 22. We divide both sides by 8. And remember, we want to reduce, okay? We never want to write out a fraction if it's not in reduced form. Both of these are divisible by 2. So x is equal to negative 11 over 4. That's how we got negative 11 over 4 instead of negative 22 over 8. We just reduced. Okay. And we still need to check to make sure it's not extraneous. Now, if you had to guess, I want you to think about whether or not you think it would be extraneous. So take a second, just think about it. Hopefully you came up with the answer that yes, we're likely to have an extraneous solution. It's not definite, but it certainly is likely. And the reason why we would say it's likely is that up here, we're squaring a negative number. And when we square a negative number, that makes it more likely that we're going to get something extraneous. So I don't want to give you a hard, fast rule because there's so many different variations on equations with radicals that I don't want you to always be sure and just say it's extraneous without doing any sort of checking. Okay, so we have 3. Remember, plug it into the original equation. So you want to plug it into this very top one over here. Okay, don't even plug it in to before you square it. Plug it into the very top one. So we have 3 times negative 11 over 4 plus 2. And yes, this one is a little bit more annoying because we have fractions and we don't like fractions. But you're going to do it anyway. Now we have negative 11 over 4 minus 4 is equal to 0. Okay. 2, you're going to switch. We're going to multiply the 2 by 4 over 4, just so that we can combine the square roots. So times 4 over 4, and this times 4, I said combine the square roots, I meant combine the fractions. Times 4 over 4. So each of these have denominators of 4. That's why we're multiplying by 4 over 4. Okay, you're just multiplying by the opposite denominator. So what we wind up with, I'm doing this in a lot of steps. You can skip some of these steps, but I do encourage you to write as much as you can. So we have negative 11 over 4 plus 8 over 4 under here, and then under here we have negative 11 over 4 minus 16 over 4. And you can see 8 over 4 is 2. 16 over 4 is 4. Okay? So that should be the case. That's what you should be seeing. So negative 11 plus 8 is negative 3. Negative 11 plus 16 minus 16 is negative 27. And you can stop here. You don't have to go any further because this is imaginary and we can't have imaginary numbers. So this is extraneous. Here. Okay, we can't get imaginary numbers. If we get imaginary numbers, how are we supposed to solve this? We would get i's. Okay, and we don't want any i's here. Just want to make sure that we didn't make any mistakes. So notice I double check too. If I get something imaginary, I just want to double check and make sure I didn't make any mistake as I went through here. Okay, just, I just want to double check my work and make sure that everything is correct. And it is, I don't see any mistakes here. Okay, let's take a few more. So we're going to do a bunch of these just so that you get accustomed to it. And again, I would suggest that at any point, you just stop and you try and do some of these on your own, okay? But I want to do a bunch with you so that you get the hang of what happens when you have different scenarios. So let's take one where we have two x's, but this time one of them is not under a radical. So here we have x plus 5. Minus x, the minus x is outside the radical, and this becomes negative 1. So our rules here are the same. We're going to isolate the radical, okay? So we're going to add x to both sides. So again, the reason for isolating the radical is because if we were to try and square this here to get rid of this radical, you cannot distribute the square. You would have to do square root of x plus 5 minus x times square root of x plus 5 minus x. So if you squared first, square root of x plus 5 minus x. I just want you to see this so that you understand why it's so important to do your best to isolate that radical. I'm going to put this underneath because we don't have enough room. Okay, this is equal to square root of x plus 5 minus x times square root of x plus 5 minus x. You cannot distribute. That is an order of operations mistake. If I see that, I will take off full credit. Okay? And then we have to distribute this, everything in the first to everything in the second. So this would give you an x plus 5, because square root of x plus 5 squared is just x plus 5. But then we have minus x times the square root of x plus 5. That comes from here. And then another minus x times the square root of x plus 5. So the minus x, the first one comes from multiplying these two. And then the second one comes from multiplying these inner terms. And then we still have the last ones, which give us a plus x squared. Notice that we can combine the middle terms. I'm putting the parentheses here. You don't really need it, but I'm putting them there so that you can just see where we got it from, that it was the x plus 5, square root of x plus 5 squared. So we haven't actually accomplished anything because we still have a radical. So this just makes our life much harder, which is why we want to isolate the radical first. It's not that you can't solve this. In fact, the way that you would solve it is you would isolate the radical and then square. So you would have to do it eventually anyway. So let's go back to this. We isolate the radical by adding x to both sides. So on this side we have square root of x plus 5. And then on the other side, I kind of like having the x first. It's positive, it's nicer to have the x first. So let's write this as x minus 1. Okay. And then we square both sides. So when we square both sides on one side, we get x plus 5. And I'm going to put in an extra step here that you don't need, but I'm going to put it in just to be sure that everybody understands where we're coming from. X minus 1 squared, again, you cannot distribute the square. I will take off all the points for this. Okay, that is an order of operations error. The only time that we could distribute an exponent is when we have multiplication or division. Here we have subtraction, okay? So this gives us x plus 5 is equal to x squared minus 2x plus 1. The minus 2x comes from minus x from multiplying these, and then another minus x from multiplying these, okay? Now, unfortunately for you, this isn't linear, right? This is quadratic. So quadratic, when it's quadratic, we have to set it equal to 0, okay? So to set it equal to 0, we want to keep our x squared positive. So we're going to subtract x from both sides, and we're going to subtract 5 from both sides. We know it's quadratic because we see this x squared. So we're setting it equal to 0. And I just prefer having my equations I prefer having the x squared on the left and the 0 on the right. That's personal preference. It's up to you how you do it. Right? It doesn't matter which side of the equal sign things go on. So we get x squared minus 3x minus 4 is equal to 0. And this is factorable. Okay, so we're going to factor it. And you can skip this step. You don't need to write this. If you can factor quickly, that's up to you. It's two numbers that multiply to -4 and add to -3. So the numbers that we're looking at are -4 and +1. Okay, so what that means is that our two factors are x minus 4 and an x plus 1. And if this confuses you, I would recommend that you go back to that video where we did the review of polynomials, because I do have cases where we factored, and just go back and take a look at that. So we use the 0 property. X minus 4 equals 0. So we have x equals 4 and x plus 1 equals 0. So we have x equals -1. Now notice we have two solutions here. We have to check both of them, okay? So we're gonna do that. I'm gonna do that in a slightly different color here, just to differentiate between what we wrote above. So we have to plug it in. We're gonna do each one separately. Square root of 4 plus 5. I'm gonna make this a little shorter so that we have more room, because we are a little tight on room here. Square root of 4 plus 5 minus 4 is equal to -1. This is the square root of 9 minus 4 is equal to -1. 3 minus 4 equals -1. X equals 4 is a solution, so I'm going to box it. X equals 4 is a solution. Now we have to do the same thing for -1. So we have square root of -1 plus 5 minus -1. Okay, be careful here. You're plugging in -1 for x. So it's minus, because we're doing minus x, minus, and then we have our -1 in parentheses, is equal to -1. So this is the square root of 4, and this becomes a plus 1. Minus -1 is plus 1. So we get 2 plus 1 is equal to -1, but this is not true. So our x equals -1 is extraneous. It's not a solution. Our only solution here is x equals 4, which is why I boxed it. Okay? Okay, let's take another one. Like I said, I'm doing a lot of examples here. If you feel like you really understand an example, you can always fast forward through it or try it on your own. I just want to give you a lot of opportunities to try different types of examples. Okay? So here we have the square root of 2x plus 7 minus x is equal to 4. So the last one that we did is very similar to this. So you can try this on your own first. So we're going to add x to both sides. Which gives us square root of 2x plus 7 on the left, and on the right we wind up with x plus 4. Again, I like to keep my x's first because I know I'm gonna have to square, and I like having it's easier for me to square. if my x is first. That's a personal preference. It's not that there's anything wrong with writing 4 plus x. Okay. And I'm going to write an extra step here. Again, you can leave this out. I typically leave this out in my work. We wind up with the 2x plus 7 is equal to x plus 4 times x plus 4. This is just to emphasize that you cannot distribute that square. Which means 2x plus 7 is equal to x squared plus 8x, because we have a plus 4x plus 4x plus 16. We have an x squared here. So notice this is why I like doing it as x plus 4 times x plus 4 instead of 4 plus x times 4 plus x. If you did 4 plus x times 4 plus x, this would be written in a different order. It would be 16 plus 8x plus x squared. The x squared wouldn't come first. So I like doing it this way so that the x squared comes first. So we have an x squared. That means that this is quadratic. So the fact that it's quadratic means we have to set it equal to 0. Again, this isn't harder. It's just more work. It's just more steps. That's it. So now we're going to subtract 2x from both sides and subtract 7 from both sides. This is to set it equal to 0. So the 2x cancels, the 7 cancels, and what we have here is x squared plus 6x plus 9 is equal to 0. And again, you can skip this step if you're pretty good with factoring. These, for the most part, you're going to see that these are factorable, okay? It's not that that always happens. It's just that I'm going to be really nice and I'm going to make them factorable so that you have a lot of different options. You can use completing the square. You can use quadratic formula if you're having trouble factoring. But factoring is the fastest way to do this, typically. So we need two numbers, then multiply to 9 and add to 6. Those numbers are just 3 and 3, which means that I'm going to move this up here. Again, just trying to save room. Okay. So that means that our quadratic is x plus 3 times x plus 3. And that means that we really only have one root here, right? One solution, x equals -3. We don't have to write x plus 3 equals 0 twice. We can just do x equals -3. And we do have to check and make sure it's not extraneous. So we have square root of 2 times -3 plus 7. Be careful in this next step. It's minus -3 is equal to 4. So we have -6 plus 7 plus 3. This is the square root of 1 plus 3. And 1 plus 3 is equal to 4. This is not extraneous. This is an answer. Okay. Okay, let's take another one. Again, this one is going to be a little bit different. This is going to be one of our last ones. Let's do 2 times the square root of x minus x is equal to -3. So the same thing is true, and try this on your own. We're going to add x to both sides. That's to isolate our radical. Now we're left with 2 root x on one side. And on the other side, x minus 3. Okay. Now at this point, we could divide by 2. That's absolutely fine. But it's probably easier not to, because why create a fraction if we don't have to? We know that if we multiply when we're squaring, like we are on this side here, this square can distribute because there's multiplication inside here. So we may as well do that rather than creating a denominator. So we distribute the square to the 2 and to the square root of x. We did something like this before. We get 4x is equal to x minus 3 now. I'm sorry, that's not true. Is equal to x minus 3 times x minus 3. That's what we get. Okay. So now we have to multiply. 4x is equal to x squared minus 6x plus 9. Okay, so now we have to subtract 4x from both sides because this is quadratic. So we have to set it equal to 0. The 4x cancels. And we're left with x squared minus 10x plus 9 is equal to 0. And again, you'll see this is factorable. We need 2 numbers that add to negative 10. Notice here I put the addition first, and here I put the multiplication first. It doesn't matter. Don't get confused by that. It makes no difference. 2 numbers that add to negative 10 and multiply to positive 9. So our 2 numbers are negative 9 and negative 1. They're both negative. Okay, so that means that our quadratic, I'm going to bring this up here, is x minus 9 and an x minus 1. Okay. We can use the 0 property. We have x minus 9 equals 0 and x minus 1 equals 0. So either x equals 9 or x equals 1. Okay, this is the 0 property. It's what we've been using all along. Here, we used it. In the previous one, we used it. I'll put it over here so that you are reminded. But we've done this before. Okay, we did it when we were solving for roots of quadratics. That's all that we're doing here. Solving for roots means solving for x. So we need to plug this back in. So we're going to start with x equals 9. 2 times the square root of 9 minus 9 is equal to negative 3. Square root of 9 is 3. 2 times 3 is 6. 6 minus 9 is equal to negative 3. So x equals 9 is the solution. Okay, let's take the other one. X equals 1. So just be careful when you plug this in that every x is being switched to a 1. Okay, that can be a typical mistake that somebody will plug in a 1 here, but then plug in a 9 here. Okay, all x's get replaced with a 1. So 2 times the square root of 1 minus 1 is equal to negative 3. 2 times 1 minus 1 equals negative 3. And you can probably already see that this gives us something extraneous. And this is going to be pretty typical, that one solution is going to work and the other solution is not going to work. That's not uncommon. It's not always going to happen, but it's very likely to happen that you'll get one solution and the other not. And this is because, I don't know why that happened. This is because it's because of that squaring. That squaring causes a lot of problems. Okay, because when we square, even though this was a positive value square, technically x minus 3, remember if it were a negative x minus 3 and we squared it, we would get the same thing. So because that squaring can yield two different answers, that's what's going on here. That's why we're getting things that are extraneous. Okay. Okay, so that's it for radicals, and we're actually going to go back to exponents in the next video.